Imagine a battlefield where no human pilot risks their life.
Yet the skies are dominated by an invisible, silent war.
We need to understand how they are moving undetected.
Could the next generation of aerial combat be fought by machines we can't even see? We're diving deep into the future of warfare, where autonomous drones are set to rewrite the rules of global power. This is not a gradual evolution. It is a profound paradigm shift.
The very concept of air superiority, a cornerstone of military doctrine since the Second World War,
is being fundamentally redefined.
to a new age dominated by algorithms, data processing speed, and the strategic deployment of attritable autonomous systems.
This article explores the technological, doctrinal, and strategic dimensions of this silent revolution.
Examining how the convergence of next-generation stealth, artificial intelligence,
and networked swarm technology is forging a new, unseen battlefield.
Section 1. The term unseen in 21st century aerial combat has evolved.
Far beyond the simple radar-absorbent materials of early stealth aircraft.
The future of low observability lies in a multispectral approach.
This new invisibility demands that platforms become phantoms, not just to radar,
but also to infrared, thermal, acoustic, and even visual detection systems.
Advanced metamaterials, capable of bending electromagnetic waves in unnatural ways, are being developed.
to create a form of digital camouflage that can adapt an aircraft's signature in real time.
However, the most profound silence is not acoustic, but electromagnetic. The next generation of combat systems will operate in a state of extreme passive awareness.
Using highly sensitive, networked sensors to build a picture of the battlefield without emitting a single detectable pulse.
Their offensive capability will be rooted in advanced electronic warfare, designed to blind and deceive an opponent's systems.
Effectively, making the enemy's own sensors and communications their greatest liability.
This shift means the first shot in a future conflict will not be a missile, but a data packet. Or a targeted electromagnetic pulse that renders the adversary deaf and blind. A form of silent cyberkinetic strike from a platform that was never truly seen. Section 2. The true engine of this revolution is not composite materials, but code.
The integration of artificial intelligence into aerial platforms is poised to compress the ODA loop.
From a human-scale process to the speed of light.
We are witnessing the evolution from remotely piloted aircraft like the MQ-9 Reaper, which are still tethered to human operators,
to the advent of true loyal wingman concepts, or collaborative combat aircraft. These autonomous platforms are designed to fly and fight alongside manned jets,
absorbing risk and multiplying a human pilot's effectiveness.
See the 2020 DARPA Alpha Dogfight trials, where an AI pilot developed by Heron Systems
consistently defeated an experienced U.S. Air Force F-16 pilot. Was a seminal moment.
It proved that in the realm of raw tactical execution, AI's superhuman reaction time
and flawless processing of complex data streams provide a decisive advantage.
The future of air combat, therefore, belongs not to the pilot with the best stick and rudder skills,
but to the force with the most sophisticated, adaptive, and trusted combat algorithms.
Section 3. The rules of global power are being rewritten by a fundamental change in military economics.
The shift from exquisite platforms to attritable mass.
For decades, air superiority has been pursued by building progressively more complex and expensive aircraft,
culminating in fifth-generation fighters like the F-35, which can cost over $80 million per unit.
Congratulations. The rise of autonomous systems inverts this logic.
A single, expensive platform, regardless of its sophistication, remains a single point of failure.
The new doctrine, increasingly explored by powers like the United States and China,
is built on the concept of distributed lethality and attritable mass.
Imagine a $200 million manned fighter jet acting as the quarterback for a swarm of 50 $500,000 autonomous drones.
This swarm can overwhelm the most advanced air defense systems through sheer numbers.
coordinated tactics, and a willingness to expend assets. It presents a tactical dilemma with no easy solution.
A high-end missile used to destroy a single cheap drone.
Point is a win for the swarm's economics.
This is how global power will be recalibrated.
Not just by the quality of the top-tier systems,
but by the capacity to produce, network, and strategically deploy intelligent, expendable mass.
the true battlefield of the future is the network.
The most decisive weapon will not be the drone itself,
but the invisible architecture that connects it to every other asset in the field.
A concept known in U.S. doctrine as Joint All-Domain Command and Control.
This Internet of Military Things fuses data from satellites, ground sensors, naval vessels, and aircraft
into a single, unified operating picture.
This is where the war will be won or lost. Checkmate. The force that can collect, process, and disseminate target-quality data faster and more securely.
Agents will be able to orchestrate its autonomous assets to devastating effect.
This creates a new center of gravity for attack. The silent, unwilling war.
As each side attempts to sever the other's data links, corrupt their data, and inject false information,
Turning the enemy's networked force into a collection of isolated, stupid nodes.
As a 2023 report from the Center for Strategic and International Studies noted,
future air dominance will depend less on the kinetic performance of an individual aircraft,
and more on the processing power of the network supporting it.
Section 5. The rise of the autonomous wingman does not necessarily signal the end of the human fighter pilot.
But it does signal a profound redefinition of their role.
The fighter ace of the future will not be a maverick who physically outmaneuvers an opponent.
Instead, they will be a mission commander, a systems manager, and an ethical arbiter.
The critical human skill set will shift from psychomotor reflexes to complex cognitive management.
Ethical scenario override.
Confirmed. From the cockpit of their 6th-generation aircraft, a node in the network. A single pilot may be responsible for directing the actions of a dozen autonomous CCAs.
Managing their sensor payloads, assigning them targets, and granting lethal force authority.
This creates entirely new training and psychological requirements.
It also places the human on the loop, not in the loop. よりもコントロールされてくることを示唆していると。Forcing them to make high-stakes strategic and ethical decisions in seconds, based on data provided by AI.
The human presence becomes a failsafe for command, control, and moral judgment, rather than the primary tool for tactical execution.
Section 6. This silent, autonomous future is fraught with profound and destabilizing risks.
The first is the ethical morass of lethal autonomous weapons systems.
The ongoing debate at the United Nations highlights a global divide.
On whether an algorithm should ever be given the authority to take a human life. The black box problem, the inability to explain an AI's decision.
Is unacceptable in a system governed by the laws of armed conflict.
Second is the risk of flash wars. When two autonomous AI-driven military systems engage,
a minor border skirmish could escalate at machine speed into a full-scale conflict.
Before human diplomats can even get on the phone.
Finally, the proliferation of this technology is a nightmare scenario, while a 5th-generation fighter is nearly impossible to replicate.
The code for a lethal autonomous drone is not.
This technology could easily fall into the hands of non-state actors or rogue nations, completely destabilizing the global security order.
The silent, unseen future of aerial combat may be one of horrifying efficiency.
But it may also be one we can no longer control.